Okay, Assalamu alaikum everyone, and hello. I hope you hear me clear and well. So I would like to welcome you all to this special event on Asteroid Day. And to begin with our today's program, let me invite Professor Ilyas Fernini, the Deputy General Director of Research Laboratories at the Sharjah Academy for Astronomy, Space Sciences and Technology, and a professor at the Applied Physics Department at the Sharjah University. Please, Professor, give us your opening words.
Thank you very much, Mariam. So, Professor Hamid Naimi, our Chancellor, and also the Director of the Academy, does apologize. So he was supposed to have the opening words, but just a few minutes ago, he said that he's busy in very, very important meeting. So I will take over, inshallah. So he apologized for that. It has been a tradition for us to celebrate the Asteroid Day. It has been, I believe, this is the fourth time that we are celebrating this very, very important event. Why is it important? Because we are part of planet Earth, and around us we have so many natural space debris, and these space debris can at any time strike planet Earth, and we don't have any kind of protection for planet Earth. Usually it is said that if we know ahead of time that one rock is going to strike Earth, maybe in about 20 years, we may do what they did in that movie Armageddon, so we can send the space shuttle. We don't have any space shuttle, asif. We may send a rocket to blow it up, and we may end up with billions maybe of small rocks falling upon Earth. So we don't have a solution. So that's why the Asteroid Day celebration comes into life. Okay, let me check if it is working. Okay, so you can go to the next slide, Fatima, inshallah. Okay, so we have been preparing for this event since more than about maybe 6 months. And if you go to the Asteroid Day website, this is our program listed and so on and so on. We were supposed to have a special Asteroid Day exposition, but we didn't do it. But at least we have lectures about this event. 12 to 1, Marwan is going to have a special planetarium show for us about maybe, well, I can say in general, space debris. And also we did have this visit to our meteorite collection, a very unique one. So in terms of the Asteroid Day, how did it start? There's a video here. You can click on it, Fatima, if it works.
So I want to emphasize that Asteroid Day is a movement to float all boats.
Asteroid Day began in 2015, gathering the best and brightest asteroid experts together with a large community of concerned citizens.
I've known some of the people behind Asteroid Day for quite a number of years, and they're smart people. So when they asked if I would help, I took it very seriously.
Through the collaboration of Brian May, astrophysicist and legendary guitarist and songwriter for Queen, and Greg Richters, director of 51 Degrees North, a sci-fi thriller about an asteroid impact. They enlisted the expertise of Apollo 9 astronaut Rusty Schweiker and Silicon Valley operative Danica Remy to grow the movement to tens of thousands of supporters. In just the first year, scores of astronauts, notable scientists, artists, and leading astronomers launched Asteroid Day by creating independently organized events at schools, museums, science centers, astronomy clubs, and in film and on television. Asteroid Day engages millions of people worldwide in support of increased efforts to find hazardous asteroids. Before hazardous asteroids find us. Asteroid. The dinosaurs never saw that asteroid coming. What's our excuse?
and it will be too late for us to react if this asteroid they do find us. That's why we need to do something about it. So I will be presenting this asteroid day. So just to give you a very nice picture of how does an asteroid look like. This is an asteroid with its moon, very strange that even these asteroids can have moons going around them so they can catch. And look at the size. Look at the size. Do you believe at the size, how small they are? And look also at the irregular shape. They are not like planets. They are not like most of the moons. They're not like stars. They have this spherical shape because in terms of physics, gravity has this kind of spherical symmetry that will form the spherical bodies. But these are small. And most of them are in between the orbit of Mars and Jupiter. So these are just what you call the leftover of the solar system. Those leftover that found themselves between Mars and Jupiter, and because Jupiter is the greatest planet, the largest planet, did not all of this whatever to mix together to form something big. So why are we celebrating on June 30? Because on June 30, 1908, some time ago, something happened over Siberia, part of what you call the Soviet Union, now part of Russia. So what was it? The story behind the Asteroid Day, objectives. Why are we celebrating? How can we achieve the goal of this Asteroid Day? Because it is not the concern of one single country, it is the concern of every one of us. That's why we need to be responsible. Our previous evaluations and also what we're going to do today, and we have chosen, alhamdulillah, so several of you that will give us, that will enlighten us about this special day. Siberia, I believe Siberia, every one of us knows Siberia. So if in the old Soviet Union, if you do something bad, they will take you to Siberia. They don't have to build a prison for you because it's an open, frozen world, and you can go nowhere here. So something happened in 1908 over this region. 1908 was a time when we had this Soviet communist revolution, the Tsar, and so on. So everyone was busy with politics. That's why they did not notice this event at all, only decades later on. So it was an explosion from which 80 million of trees were devastated. Do you believe that? Over about 2,000 kilometers square, unbelievable large area. No impact crater. Do you believe that? No impact. And we believe that that object that did create this problem was about 5 to 10 kilometers big. I'm sorry, it was like grazing Earth atmosphere, 5 to 10 kilometers, and it was between 50 to 190 meters. And look what it did. A flat area. 80 million of trees were devastated. If it were over a city, there would be millions of people killed. So that's why this event is very important. It is a reminder that planet Earth is at risk at any time. Yes, we do have telescopes observing our sky. I believe we have cataloged most of the big ones, but we are left with the small ones, 5, 10, 20 meters, 5, 10, 20 meters. We may say that this is nothing. It is a small one, but it will come with very high speed, as fast as the speed of a bullet. And you can compute the energy to be huge. Like you may have the result maybe of 100 atomic bomb falling over your city. So to be a big disaster. So we need to do something about it. That's why these two people, the late Stephen Hawking and also this filmmaker, Gregory Richter, he came to us in 2018. We did invite him with his wife because he was the co-founder of this Asteroid Day. So the United Nations declared June 30 to be this international day where we need to celebrate, not to celebrate for sure, but at least to remind us that this space around us is not peaceful. So we need to do something about it. So a lot of people, a lot of scientists, a lot of astronauts, they did get together to have this declaration. At least it has been signed by all the UN nations, and that's why it is celebrated worldwide. So the objective of this Asteroid Day is to raise public awareness among people that we live in a very unsafe place, And it is not the problem of one single country. Maybe some people say it is the problem of superpowers. They have these space agencies and they can develop some space program to save planet Earth. No, it is the problem of every country. That's why we need to find something in order to save Earth from this asteroid and also other space debris. So, and also we need to be able to have a program that can detect this space debris. Yes, we have tens of these automated telescopes on the Earth that do observe, and anything that does move, it will get detected. We have our own Sharjah optical observatory here, and it can also do the same thing, but it is not enough. We need to have more than that, especially if we can have some space assets, some spacecraft that do this observation for us 24 hours. So we need to be a little bit prepared. But are we prepared for such an impact? So this is quite devastating for us. So how can we achieve the goals of the Asteroid Day? Well, we need to have new technologies to track this, what you call near-Earth asteroid, and one of us will talk about it later on. We need, at least we are discovering, yes, but we need to have these discoveries of this space debris to be rapid. Let's say 104 acceleration of discoveries. And also we need to, for this Asteroid Day to be adopted worldwide. That's why everyone should be concerned. Every country that has a space program that has maybe an observatory should at least have a program observing this asteroid on a daily basis. There is a very, very nice animation here just to let you know how, in quote, how dirty is space around Earth. Can you run it, Fatima, please, this video? This is all the asteroid between January 1, 1999 to January 31st, 2018. And the colors are very important. The blue ones are the near-Earth asteroid. The orange represent the main belt. As I say, between Mars and Jupiter, we have this asteroid belt. Okay, it's working. So it is an animation. Can you reduce the light, Anas? So it's getting populated year after year. It's like a zoo. This is the asteroid belt. And look how populated it is of these leftovers. So we are not safe, period. Past celebration, just to let you know that we have history about doing this every year. So this is 2018. This is when we invited Dr. Gregory Richter. He's, as I said, the co-founder of the Asteroid Day. 2019, Aisha, mashallah, here with some school kids here around. This is what we did 2020. I believe it was an online because of the COVID. 2021, it was also online because of COVID. And by the way, so just to thank Abdullah Masood about what he is doing since more than about maybe 3 years, I believe, 3 years. So every morning we publish this map, recognize Saudi Arabia, UAE. So every morning this map is generated. What does it do? It will check of any possible space debris. Here, what do I mean by space debris? I mean an artificial one, like a falling rocket, a falling satellite over the Middle East. You can see here, number 1, survive, no, this is the Indian Ocean. Number 2, yes, it did survive, here's number 2 here. Number 3, no. So every morning we get this map that is very, very useful for us. So if you'd like to subscribe to this, so please send to Abdullah Masood your email and you will have it every morning. So that every morning when you wake up, you can say, today I won't be struck by a satellite. I will still be alive, inshallah. Okay, so what we'll do today for you. So besides, for sure, I know that you're all waiting for the lunch, not for the lectures. That's fine. So Mariam Sharif is going to talk about the different asteroid missions that we had. We have plenty of them, even some space mission like Cassini, like Galileo, that were not meant to study asteroids, but they did a flyby. They did flyby of these asteroids, so she will talk about it. Fatma Al-Khati will talk about what the Sharjah Optical Observatory is doing in terms of observing this near-Earth asteroid. Anas is going to talk about the UAE, which we call the UAE Meteor Monitoring Network, 3 towers. Aisha Rawis using AI to identify these Earth impacts asteroid. And Salma Sobhi will talk about the impact craters we have on Earth. We had during the bombardment phase of Earth formation, we had millions of them. But since Earth is an active planet, we are left with only about 200. We believe only 200. If you look at the moon, you see millions. If you look at Mars, you see the same number. If you look at Venus, not directly, for sure it has this cloud, and Mercury, they have millions. But planet Earth is very active. So because of erosion, because of winds of water, we have only about 200. But Earth was impacted, if we do believe for sure this Earth formation story. Then I will conclude with some remarks, inshallah. So please, I hope that you will enjoy these lectures, and please, you are free to ask any questions. Great. Mariam, it is your turn, inshallah. Thank you very much. Please. Asteroid is something big, and that's very, very interesting. Asteroids are, you know, like the planet Earth, like we have a unique like the asteroid. You know that question? Thank you very much.
Thank you, Professor Ilyas, for enlightening us with the story behind the Asteroid Day and the importance of such an event to raise the awareness of such a threats that could cause our planet Earth. So let me now start with the next topic about asteroid mission. And to begin with, first we have to define like what are asteroids. So asteroids are small rocky objects that orbits around the sun. So that's the basic definition. Now, asteroids can be classified based on their compositions as the following. So we have the first type of classification. Okay. The C type, the chondrite asteroids, which is the most common type, and it's mostly can be found within the asteroid belt. And then we have the C type, the stony type of asteroid, which is mainly made of silicate minerals and the nickel iron. While the third type is about the M type, which are the metallic nickel iron asteroid, and they are really rare in our solar system. Now, there are further classifications for the asteroids. So based on where we can find these asteroids or where we can see them in the solar system. So the first one is about the main asteroid belt. So as you can see, between the Mars and Jupiter, there is like this gap that is filled with these rocky bodies that is called asteroid belt. And most of asteroids that can be found within this area. However, some asteroids can be found in another location, which are called the Trojan asteroids. These Trojan asteroids, basically, it's a special case that can be found within like the orbits of larger planets. And we'll see in the upcoming slide more examples about these Trojan asteroids. The third type or the third classifications of the asteroids are the near-Earth asteroids. Now, this type is the most important type to study about because they might cause a potential threat to our planet. So you might ask yourself why it's important to study out these asteroids and why we send such a missions, spend all of that money to go through that journey and to be there to study these asteroids. So because of their value, so they are mineral resources, and to study and explore these asteroids that will give us a hint about the formation of our solar system. And beside that, to provide a protection to our planet. So by tracking these asteroids using several observatories here in ground and up in the space to track these objects and possibly deflecting these asteroids if they might cause a threat. Now here in the slide, we have several types of spacecrafts. So as can be classified in this. So the first one is the flyby spacecraft. So the flyby spacecrafts, they just fly by their name throughout the object that wants to be studied. So they don't orbit, they just pass by through that object. While the orbit spacecrafts, they do orbit around that object, whether it's a planet or, for example, asteroids. And the atmospheric spacecraft, they are dedicated for the atmospheric studies within the atmosphere. And we have the lander spacecraft, where they land on the target object. Now, the penetrator is another case where it gets to penetrate that body to get deep into the soils, to have a deeper knowledge about that specific body. And of course, we have the rovers, the observatory spacecrafts, and communication navigation spacecrafts. So if we want to define the mission, so we can define them by the different type of the spacecraft that could take it into it. So to start by the flyby missions. Now the first mission that went through the asteroid is the Galileo. Now Galileo was named after the Italian astronomer Galileo Galilei. This mission was mainly about to go to Jupiter to study out the Jupiter planet. So it was launched back in October 1989, and it reached to its destination, Jupiter, in 1995. So using, of course, the space shuttle Atlantis, you might be aware about. And it spent 8 years studying the larger planets in our solar system, Jupiter. But while going through its path or its journey toward its target mission, it passed by 2 asteroids, which the first one which was the humanity's first encountered with an asteroid back in 1991 with the Jaspera asteroid. Now this asteroid is an S-type asteroid, and it has a mysterious flat areas within the object. So it might be due to several impacts that could cause it, and it might be just like these cars where because it was broken from its essential parent body. Now, Galileo made another historic record as it passed by the Ida and its tiny moon, Dactyl. So as Professor Ilyas already mentioned this in his presentation earlier, so what's unique about this object, because they are really rare, that we have these asteroids with their moon that's orbiting around it. So, and it was the first known asteroid with a moon, but there was another mysterious thing about it, as this asteroid and its moon were turning red over time. So they wanted to learn more about it. So that's about the first mission here we have. And there are several other missions that it's like this within the same case, that it was targeted towards a comet or towards another planet, for example, Saturn, and it passed by several asteroids to do the study. So they just flew by that object. That's in the past, and we'll move to the current time. We have the Lucy mission, which is the first mission to the Trojan asteroids. So as I've mentioned earlier about the Trojan objects, so we have, this is the Lucy spacecraft, and it was named after the Lucy fossil. Now, because Lucy's fossil had made like a major new understanding about the evolution, so because this mission or this spacecraft will make a new understanding and evolutionary about the solar system, because it will study specific objects that are called the Trojan asteroids. So here we have in this image, so we have the Jupiter here, and as you can see, there are swarms on both sides, before and after Jupiter. So these swarms are filled with these Trojan asteroids. So why these asteroids, they became within this style, you can say. So there is a theory that as like the planets were moving and migrating away from the sun, there is a chaos that happened, and a distraction of all of the space bodies were moving away from the solar system. Now, when these objects reached to this specific location, they got trapped. And once they entered to this, toward these areas, they couldn't leave. So they just entered and got stuck there. So to better understand why does this happen, because as you can see here, there are several points, as you can see, and they called the Lagrange points. So these Lagrange points are stable regions in space, and they are mostly found around the planets. But because Jupiter is the largest planet, so it contains the most or the greatest amount of these Lagrange points objects. Okay, so as I've said, that once these asteroids came into it, and they couldn't leave out from that point. So what is also interesting about it, as you can see here, there is a 60-degree here and a 60-degree here that could cause that stable regions due to the attraction, the gravitational attraction between the sun and the other planets, as you can see here. So that's about the Trojan asteroids. To go further to know more about the Lucy's mission, so Lucy is going to study 7 objects, one of them of the main asteroid belt. So here we have the Lucy mission trajectory. If we could just lower the lights, please. No, because it's bright, the lights, just dim the lights. I hope you can see it clearer now. So Lucy passed throughout the first object here, which was within the asteroid belt. And it's named the Donald Johanson asteroid. And then it passed through the other. Here we have just a replayed video. So you can see that's the trajectory. This is the Earth, of course. So using the Earth to drag it and to push it toward its path, that it was just made the first flyby through the asteroid belt object. And here we have the other Trojan bodies from the first swarm. So now it's moving toward the other two objects, which are two symmetrical objects in size, basically. They are called the binary asteroids, the Patroclus and the Minucius asteroid. So what is unique about it as well, it's not just because it's further away from our planet and away from the asteroid belt, but it's the varieties of these objects. So they have different forms. For example, some of them are stonian, some of them are iron asteroids. So the different characteristics of these selected objects could cause that evolutionary results. Right, so it will study 7 asteroids in 12-year span. And here we have some scientific instruments of the Lucy's mission. So the first one will basically measure the composition of the surface. And the second one will get a black and white images that could give us the geology and the crater's history, which we can tell about the age of that surface. The third one will measure the temperature of the surface at different points. Now, these are the three scientific instruments. And along these two, there are subsystems, but they can be used within the scientific purpose for this specific mission. So that's about the flyby missions. So now, what about the orbital missions? Now, here we have one of the most important mission, the O-series mission, because it's studying a potentially hazardous asteroid, the Bennu asteroid. So it's an orbital mission that it was launched back in 2016. And it will not just orbit around that asteroid, but it will even capture some samples to return it back to Earth, which is really interesting to get even further to study out these samples. So this spacecraft have already left the asteroid back in May 21, and it's scheduled to deliver its cargo, the samples, in September 2023, inshallah, next year. Now, Psyche is another mission, and this is the upcoming mission of NASA's plans. Sorry for that. So this mission will specifically study a metallic asteroid, so an iron asteroid, to give us an insight about it, because they believe that it might be like a part of a core of a planet that is just dispatched from it. So here we have an artistic image of the Psyche asteroid, and this is the spacecraft. So yeah, it will arrive at its target in 2026. So we have already saw about the flyby, the orbital missions, and now about sampling missions. So these missions that will bring us some samples from these asteroids. So the most famous ones are the Japan's Hayabusa sampling mission. So the first one, so it's a Japanese spacecraft that was launched back in 2003. And its objective is to study this Itokawa asteroid, which is also a potentially hazardous asteroid that is always periodically crosses the Earth's orbit. So to get a closer look into it and to get some samples. So it made a success to visit and to take some samples, and the samples were returned back in 2010. So after this successful mission, they launched another mission, the Hayabusa 2, which was launched back in 2014. And this mission will study another asteroid, which is also a potentially hazardous asteroid. So they have deployed a series of small robots to grab up samples, and they also made an artificial crater into that asteroid. So to get a different insight about what is deeper down that asteroid. So the samples are from the Ryugu surface, as well as of that fresh crater that was made. So the samples actually were deployed into the Earth atmosphere in 2020. So the mission engineers, they decided to go further to other asteroids. So they just dropped their samples into the atmosphere, and they continued toward other asteroids. One is a fast spinning asteroid that's still, this is the current naming of that asteroid, and it will study another asteroid while going to that final object. So now, if you see that some hazardous asteroid, that if they came toward our Earth, so how we will defend ourselves? Is there are like missions to defend ourselves? So you might just think, why we don't just throw out a spacecraft to that object to create, for example, a hole to, so just to crash that asteroid, that spacecraft. So that's what NASA's actually doing, the DART mission. So this is a totally new mission under the planetary defense missions to establish it and to just crash it into that asteroid. So using the kinetic impactors, where they will like create a hole throughout that asteroid that will cause it to change its orbital direction. And then after that, yes, and it will be captured by another CubeSat that it will be deployed from the spacecraft itself to just capture that impact, we can say. And later on, there is the European Space Agency missions called HERA. So they will go to study out that effect that was done after the dust will be settled down. So here is an animation that you can see how this asteroid will go and will just impact out that asteroid. Okay, so that's about international missions. Now we have this upcoming future Emirati mission, the ambitious mission to explore the asteroid belt and some asteroids in the asteroid belt as well as Venus. So back in October 2021, the space agency announced this ambitious mission for an interplanetary mission to be evolved. And this mission is scheduled to launch in 2028. So to have a further details, we'll have this video to show us more details about this mission. So with that, I conclude this topic. Thank you for listening. And if you have any question, please let me know. Yes, please. Yes. Mm-hmm. Yes. Yes, so that one that you have just mentioned is a really rare type of asteroid, the G-type asteroid. So just to go back to that. All right. Yes, so these are the three main types of asteroids, but yet, as you mentioned, the G-type is a really rare type of asteroid that is not mainly classified as a main asteroids classification. So I hope that answered your question.
So I don't know why it's rare.
It's not written here, but it's, yeah. But it's one of the missions is visiting an asteroid within that type. Maybe I haven't just mentioned it. Yes.
Jessica, I heard that NASA has big problem, but solar panels is not. But they still decided to go to Jupiter.
Yes.
They will try to solve the problem of because without the solar panels, this spacecraft will have no power to function. So it's very, very big loss if they can fix the problem.
Exactly, exactly. As this mission is going further away from the sun, so it's really hard to get that solar ray. So because of that, they are having a really large solar system.
Only one mission
impact with the sample?
No,
Like
it's not.
Hayabusa still hit.
Yes, one,
And
two.
the sample destroyed, or the container smashed while hitting the air. And they collected that sample. I don't know how did that. Just a few grams.
It's few grams.
Yeah.
Yeah.
And the content is smashed down by air.
This was from Hayabusa 1. So
That one,
yeah, was a big loss. They collected
but
and
it's already, yeah.
smashed on the ground.
First, yeah, contaminated air.
Yeah,
Right.
as they had challenged really hard to open that containers of the Hayabusa's 1 samples. So it took them a long time to just open it and take it out to try to analyze it further.
But the most interesting project is that
Yes.
this will be like a unique experiment. To go into an asteroid, try to impact it, have a CubeSat recording everything, and try to see if this impact is going to move that asteroid. Because this is how people are thinking about deflecting the asteroid by impacting them. So does it work? Is it that satellite, does it have enough power to change maybe by the millimeter the orbit of the
Yes.
so it's good to wait and see if it works.
Sure.
Thank you very
Absolutely.
much.
Thank you so much. Thank you. So our next talk will be about the Sharjah Optical Observatory's asteroids discovery. Will be given by my colleague, Ms. Fatima Al-Khatri, scientific guide at the planetarium. And she's also studying her master's in astronomy, space sciences. So please, Fatima, please. Good morning, everyone. My name is Fatima Khatri. I'm going today to present an important topic, which is observing near-Earth objects with the Sharjah Optical Observatory. So in this talk, I'm going to introduce you with what are near-Earth objects, how they are classified, what are potentially hazardous asteroids, and where they are located. In the next part of this talk, I'm going to present my research paper. So let's start first with what are near-Earth objects. Basically, near-Earth objects, any object in our solar system, such as a meteoroid, an asteroid, or a comet, that can be recognized through its tracks. They are orbiting around the sun with the perihelion distance less than 1.3 astronomical units, and aphelion distance greater than 0.2 to measure distances within the solar system. And it is the average distance between the sun and the Earth, and it is about 150 million kilometers. And what are aphelion and perihelion? What are aphelion and perihelion? Aphelion and perihelion are described the furthest and the closest distance the Earth is to the sun. For example, at perihelion, our planet is about 147 million kilometers from the sun. And at aphelion, our planet is about around 152 million kilometers from the sun.
So as you can see in this image, our planet is closest to the sun, and it is perihelion about 2 weeks after the December solstice. And our planet is furthest from the sun about 2 weeks after the June solstice. And now let's move to the classification of near-Earth objects. We have different classification of near-Earth objects. Firstly, we can classify them based on their kind and size. And we have 3 groups, as you can see in this table: near-Earth meteoroids, objects close to the Earth's orbit having a diameter of less than 50 meters. And then we have near-Earth asteroids, objects near to the Earth's orbit having a diameter of more than 50 meters. And the last group is near-Earth comets, objects in proximity of Earth's orbit. Also, we can classify near-Earth objects into 4 categories based on their aphelia and perihelia of their orbits, or let's say based on their orbital elements. And we have, as I mentioned, 4 categories. First one, Amur group. This group of asteroids is located between the orbits of Earth and Mars, as you can see it here. Although they may occasionally cross the orbit of the red planet, but they never cross Earth's orbit, but they can come close to it. And the second group is Apollo group. Apollo group, this group of asteroids have an orbit which is their perihelion is smaller than Earth's aphelion. And this aspect makes these asteroids to cross Earth's orbits and making it to become potentially candidates for a future collision. And the third group is Athens group. This group of asteroids have an orbit which is their aphelion is greater than Earth's perihelion. So this group is like Apollo group. They also occasionally cross Earth's orbit. And the last group is Ater, also called Apophili group. And this group of asteroids have an orbit is entirely confined with Earth's orbit. They don't cross Earth's orbit, but they may come close to it. And now let's move to what are potentially hazardous objects. Basically, they are defined on the parameters that measure the asteroid's potential that make threatening close approach to the Earth. Specifically for all asteroids with an Earth minimum orbit intersection distance of 1.5 astronomical unit or less, and the absolute magnitude of 2020 or less are considered as potentially hazardous asteroids. And you can see here in this image shows more than 1,000 orbits of potentially hazardous asteroids. And now, where they are located, most asteroids are located in a region between Mars and Jupiter, as you can see here, known as the asteroid belt. But also asteroids can found here in this orbit can share or can be within the orbit of others planet and known as Trojan asteroid. As you can see here, this Jupiter's Trojan that share the same orbit of Jupiter and occupy a stable Lagrangian point, which is L4 and L5. And on the left, you can see this. This is the time-lapsed animation. Shows the movement of Jupiter's Trojan during the time during the Lucy mission, which is my colleague Mariam mentioned. And by the way, Lucy mission is the first spacecraft to explore the asteroids Trojan. And now I'm going to present my paper. Basically, our paper is about to present the results of 3 asteroids observing with 3 near-Earth asteroids observing with Sharjah Optical Observatory. Those asteroids are Apophis and 1998 OR2, also G99R45M. Diameter, mass, hyperbolic axis velocity, impact velocity, and kinetic energy were calculated, and the effect of the asteroids impact on the Earth was predicted and then compared to those of Arizona meteorite. So when it comes to Sharjah Optical Observatory, our observatory consists of 3 telescopes, but the main one that we use it here in this research is CDK plane wave telescope, 17 meter in diameter, and is specialized for observing asteroids. Also, our observatory has its own code, which is M47. So, as I mentioned, we have observed 3 near-Earth asteroids and are classified as potentially hazardous asteroid. However, due to time constraints, I'm going to talk about just one asteroid, which is Apophis. Apophis was discovered in 2004 and also belongs to Earth's crossing asteroid known as Athens. Another thing about Apophis, according to the scientists' estimation, it will pass close to the Earth's orbit within 31,860 kilometers from its surface on April 13th, 2029. Also, you will see here in this picture, it has a peanut shape. Now, this asteroid was observed by my colleague, Mr. Mohammed Talafha, during one night, and it was imaged 6 times on 2021 February 22nd. And as you can see here, the observations and the orbit of Apophis. As you can see, this is the orbit of Apophis. Crosses Earth's orbit, so that is classified as Athens group. And now we have calculated the impact parameters of this asteroid. First, let's start with the diameter. If we want to calculate the diameter of any asteroid, the diameter can be calculated through its absolute magnitude. As you can see, this is the absolute magnitude, and the lower the H value, which is the absolute magnitude, the larger the diameter of the object. But this requires to know the asteroid's albedo. And here, the Apophis albedo is obtained from NASA database, as you can see here, which is 0.23. And the albedo is range between 0.05 and to 0.5. And then we have calculated the mass. The mass can be calculated through its density and diameter of the asteroid. Here, the density of Apophis is assumed to be 2.6 gram per centimeter cube, because I have assumed like this because as my colleague Mariam mentioned, we have different type of asteroids. We have S class, C class, and so on. So Apophis is S class. So according to the chemical composition of the asteroid. And then I have calculated the hyperbolic axis velocity. Hyperbolic axis velocity is relative velocity at atmospheric entry without estimating the acceleration caused by the Earth's gravity. And we have calculated the hyperbolic axis velocity from Obic's encounter theory, as you can see it here, but we need to know the orbital elements of the asteroid, which is eccentricity, inclination, semi-major axis, and so on. And then we use the value of hyperbolic axis velocity to calculate the impact velocity. And then, since we have mass and impact velocity of this asteroid, we can calculate the impact energy. Finally, after we done with the calculations, we can compare it with any asteroid. For example, in this paper, we compared our calculation with the Arizona meteorite, and we can predict the asteroid's impact on Earth after the collision. And thank you.
So if there are any questions? Okay.
So what was the result about when you compare it with the Arizona meteorite? Bigger or smaller?
Exceeds Arizona meteorite parameters.
1,000 kilometers.
Yes, because as you can see here, the diameter of Apophis, we found it 321 meters, but Arizona around 50 meters. La, inshallah. Do you have any questions? Okay.
Right, so we thank Fatma for the informative lecture and for sharing her research results. So we'll move on into another lecture, which is also one of SAASST research projects with my colleague, engineer Anas. He's a lab engineer at the Sharjah Academy's laboratories. Please, Anas.
Okay, assalamu alaikum everyone. My name is Anas Adwan. As Mariam introduced me, so there's no need to introduce myself again. To begin with, usually whenever we look for asteroids, we use the observatories or we use telescopes such as the ones we have in the Sharjah Observatory here at SAASST. But whenever we're looking into observing smaller chunks, we use other means such as the optical CCD cameras. Here at SAASST, we use the UAE meteor monitoring network in order to observe the sky and monitor the meteorites that cross over the UAE. The mission of the UAE Meteorite Monitoring Network is to establish a very unique system in the Middle East and North Africa. It also aims to observe and detect meteorites that cross the UAE, and afterwards to analyze them and possibly get the landing location of them. The project aims to take part of the UAE space situational awareness, and that engages the public with the meteorite or asteroid related events. The network locations, as you can see here over on the map, we have 3 towers at the moment. The first one located in Sharjah, which is here at the Academy. The second one was built in Liwa, Abu Dhabi. And the third one was built in Liwa, Al Yahar. Tower structure. To begin with, here are the pictures of the towers that we have. This is the one we have in Sharjah, and this one is located in Al Yahar, and this is the third picture of the tower we have in Liwa. So this is the structure of the tower we have. It's basically divided into 3 different sections. The section at the bottom, which is the operating room. This is where we have the computers. We have all the equipment needed to run the system. This is where the magic happens. And the section in the middle is the service section, is the service area. This is where we have access to the cables. This is where we have the compressor for the AC. And the section at the far top is where we have the cameras. This is where we do the adjustments of the cameras. This is where we perform the maintenance as well. So here is a top view of the towers that we have. As you can see here, we have 16 cameras. There is a unique pattern. They're not randomly just placed on top of the towers. So there is a pattern of the cameras. And as you can see here, I'm not sure if it's noticeable, there is a camera in the middle. That is the all sky camera. Speaking of cameras, here are the camera details. We do not have one type of camera that has been distributed all over the tower. So there are 3 types of the cameras that we use. We have one CCD camera with a 2mm lens, which is the all sky camera located in the middle, as you can see over here. And we have 10 CCD cameras with 8mm lenses and 6 cameras with 6mm lenses. As you can see here, this is a map of the sky, and as it's noticeable, there is a unique pattern. They are not just randomly placed. So we align the cameras that we already have in order to get the maximum coverage of the sky. So as you can see here in the red squares, we have the 8mm cameras coverage, and with the blue boxes, we have the 6mm cameras coverage. The data handling and transfers. So as an asteroid gets captured, it initially gets stored in the tower itself. And the day after, my colleagues here at SAASST, they control the towers. So they remotely connect to the towers and they filter the data that they have got. And afterwards, they store the data and send them for further analysis. Examples of captured meteors by the UAE Meteor Monitoring Network. This is a very interesting picture that we have. This is a stacked image of the same camera in the same tower. So over the time, as you can see here, the time is overlapped. As you can see, there are many different captures, many different asteroids with so many different directions and different brightnesses from the same camera on the same tower. This is a very bright meteor captured in daylight. This is, as you can see here, it was captured at 5:30 in the afternoon. So imagine how bright would it be if it was captured at night. This is another captured meteor. This was captured at almost 1 a.m. Two more examples. This is one of the latest observations. As you can see, this is a very bright capture. Double and triple detections. What we mean by double and triple detections is whenever we have the same object detected by different towers, may it be 2 towers or 3 towers. So why do we benefit, or why do we look into double or triple detections? Because it helps us later on in doing the analysis, and it gives us a better result in pinpointing where would be the possible landing location. Double meteor, not a double detection. As you can see, there are 2 meteors following each other in this section. And this is a unique capture as well of the Milstar satellite. It's over there. It's supposed to be over there. Yeah. And this is a picture of it, a screenshot. The UFO capture. Basically, the UFO capture is the system that's used in order to capture the objects. So this is the user interface. As you can see, this is a view of the camera itself. And on the left side, this is the information that's plugged in order to identify which camera that we're using. So an example of the information that we put is the longitude, the latitude, the lens of the camera, where is it located, what's the number of the camera. So as you can see here, this is camera number 16 with the lens of 8mm. So whenever we get the data later on, we know that this camera, this capture came from this camera. And this is a picture that I insisted to keep in this slideshow because this is my greatest enemy. So as you can see, this is the old sky camera to us, but to them, this is either a couch or a bathroom. So whenever they leave, they always leave residue, let's say. So through the slide, we can notice exactly to clean after them. So the limitations that we get usually are birds residues. They always give us false detections. Also insects give us false detections, planes, rain, dust. So keeping or maintaining the towers is very essential in order to get useful results at the end. UFO analyzer and the UFO orbit. So after getting the data from the tower, after doing the filtration, after getting the useful and deleting the false detections, we go through the analysis in order to get what we need in terms of pinpointing where is the landing location. So we go through the radiant sheet, we go through the orbit sheet, the trail map, the ground map, and at the very end we get the landing location. Network timeline. In 2018, September 2018, we built the first tower, and by the end of the same month, we built the one located in Liwa, and a few months later, we built the latest tower we have, which is in Al-Yahar, and it does not stop there. The network statistics, as you can see here, we have 3 labels with 3 different colors. We have a label for Sharjah, Al-Yahar, and Liwa, and as you can see, the tower with the maximum readings is the one we have in Liwa because it has almost 0 light pollution. The one we have in Sharjah here is in the middle of the city, and the one we have in Liwa, in Al-Yahar, it's relatively far from the city, but the one we have in Liwa, it's in the middle of the desert, which gives us a perfect sky. It's pitch black, and we can notice everything that happens. So here are some readings or some statistics. The total number of detections are 41,000 detections, and 5,000 of them are double detections, and 450 triple detections. Here are some of the publications that we have. We have participated in conferences and we have published some papers, and they're available for you in case you need them. Future extensions. As I said, it does not stop at building Al Yahar tower. We are planning currently on adding 3 more towers. So as you can see here, the red marks represent the new locations. The old locations. This is the one we have here in Sharjah, and this is Al Yahar, and this is Liwa. So the green locations will be the possible new locations. This will be in Ras Al Khaimah, covering the north, and we have a location here. This is the most important point to me, because as you can see, if we added this point, we will have so many double detections. And far to the west, we have a new possible location as well. And by that, we will get the maximum coverage of the UAE sky. And in addition to that, we're going to modify the cameras. We're going to have better and more sensitive cameras. And we are modifying the design of the towers in order to make it a little bit more user-friendly. And by that, we reach the end of my presentation. Thank you very much. Which one?
Maybe I need to clean your
Right. I believe your question your question was about why the numbers are getting lower and lower by each year.
this is the first one is about December 2021.
Yes.
December 2021 in Sharjah, you have the max now, compared with the Lima and Aliha. That's the blue line over there.
The problem of this is COVID time. We had the Lima tower, not working. And we cannot send analysts because of COVID restrictions. The only one tower was very well working because it was service in Sharjah.
Good solution there.
Yes, because of the service network. So we're almost blocked, and I believe the Liwa tower, you may correct me, Anas, the Liwa tower had this program, something like that. So
Yeah, at some point, Liwa was down.
and for more than 5 months, we were not able to go to it because the program was closed.
The whole reason
For that, I can answer to that, because over time, as you know, we have connectors, we have cables, we have cameras, and we play a huge role on cameras. As you know, when cameras when they're exposed to heat for instance, 2015 to now, they pixelate over time. The cameras become worse in terms of resolution. So over time, yes, the quality goes back, and we have reached to the point where we need to replace everything. So at the moment, we are in progress of replacing the whole system. We're going to replace all the cameras, the connectors, and the
paper about this point, the installation of the CCTV camera. Go to the manufacturer, you get some fund from them to do that, and report the special journal about this. It's quite important. For use right away.
And there's also one factor that the reporting of tables, because we can standardize the way. Sometimes cloud will not be there, so probably there not cloud. So also one important factor, all of this. So sometimes it's full moon and we have a meteor shower. So but all of these factors are important.
Thank you. Can I ask a question? Yes, follow. After analyzing these, particularly double these levels,
And it's not happy.
happy?
Is it happy?
How is it?
Yeah, happy.
Yes, happy.
حبيب بدل بنصير هات حبيب. Okay. So after analyzing the double and the triple numbers, I think that we need to find those default orders. Am I right? Yes. But more importantly, is not to find that, find out the orders within to analyze that soil itself. So how would these things and did we have any research?
As you can see here from using software that we have, this will help us find the source. So we do have some research and we do have some analysis that has been done in order to find the source of the asteroid. The after right, the orbits of this
We have some.
yes, the application does orbits access.
Very important. Very, very. The origin. We have it. We found it.
But this is even for the noun meteor shells. And now it's like part of our elimination and also observe your meteor at least over 3 towers are not enough. Sorry, I will be able to have it was to define the orbit, the phases. Need at least 3 observations of 3 points. So having the same meteor observed by more than 3 towers will facilitate the exact observation. And this is what we are looking for. And it's very, very important for this research. But we cannot do it.
This one, yeah, Sharjah will have. Great. Any other questions?
So thank you, Engineer Anas, for introducing us to the UAE Meteor Monitoring Network project and sharing the detailed or technical details of that project. So for now, and I hope you don't feel sleepy, because I feel some people are feeling a bit sleepy. So I hope to refresh you now with the upcoming topic about observing or detecting the hazardous asteroids utilizing AI, the artificial intelligence techniques or applications. So our next speaker will be Ms. Aisha Al-Uwais, a research assistant at the Meteorite Center as well as at the Artificial Intelligence Lab. So she's the best one who would tell us about this topic. So, please, Aisha.
Assalamu alaikum, everyone. Good morning. I'd like to start my presentation with this video. So usually when we think of asteroid impacts, a similar scene is what we imagine. An asteroid, if it hit Earth, it will either wipe out forms from Earth or cause damages like we saw in Tunguska in 1908. Now, of course, there are mitigation plans developed by different entities worldwide, but we cannot execute them in a timely manner if we did not predict them beforehand. This is where artificial intelligence comes in. So before we begin, we need to define what is AI. AI is basically a field of computer science. It is an applied concept that aims to do the following: make machines think like human beings. Today, we are limited to 2 types of AI, which is machine learning and also neural networks. For further details about AI, join us next week on Wednesday at 12 p.m. Now, to get data about asteroids, where can we get them from? We can get them from ground-based observatories like the Sharjah Observatory, space-based telescopes, and also radars. And if we want data about meteors, where can we get it from? Where? UAE and Anas's presentation. So only after getting data, we can start with data processing and feeding it to the AI system. So this is the first project I'll be talking about. There will be 7 of them in total. So here are the numbers of the project. This project is identifying Earth impacting asteroids using artificial neural networks. This was by the University of Leiden in Netherlands, if I'm correct, in 2019. So the aim was to identify Earth impacting asteroids. How about the data set? It was built using DASTCOM dataset, which is a database containing all asteroid related elements from NASA JPL, and another dataset, they called it simulated non-impactors. So the idea is they simulated 20,000 years ahead of the solar system at the moment from 2018 and 20,000 years forward. Then they integrated it backwards. So this animated image helps you understand it. So we go 20,000 years ahead and we come back. Why? So we can know the trajectories of the objects that collide with Earth. And this is another image just to show you a representation of how asteroid trajectories look like in a simulation. So the dataset classes in AI, we need to have classes so that we can train the model on. The first class was potential impactors. The second class was unidentified objects. To make it simpler, if we think of meteors, we have class of meteors and class of not meteors like birds or other source of noise. So here we have the same, potential impactors and unidentified objects. Basically, those are the expected outputs from the neural network. So the number of objects from the DASTCOM was above 700,000 images. And from the simulated KIs, it was above 300,000 images. Trajectories. Those come in text, not images. So those are the input parameters. We have the semi-major axis, eccentricity, and the rest. Those are the orbital parameters of an asteroid. And then they are fed into this neural network. As we can see, we have 5 inputs here, and we have 2 layers. Those 2 layers are responsible for studying how a potential impactor is supposed to look like based on these input data. And they called their neural network hazardous object identifier, or HOI. What is the benefit or the result of this is the following. First of all, their HOI was able to identify 95% of the KIs that as potential impactors. They were also able to say that 90% of the PHOs were correctly identified as PIs. Those are the potentially hazardous objects. They are identified as such by NASA. And this neural network did not see this data before. It was not trained on it, so it was able to predict it as PIs. Remember the first class. It was also able to classify 11 asteroids as potential hazardous objects that were not listed by NASA. Here we can see this table. Fatma already explained what makes an asteroid dangerous or not. First of all, this is the closest approach, 0.02. They have to be less than 0.05. And they also have to have a magnitude of 22 or less. And finally, the arc days should be 31 or less according to, those are the parameters set by them. So if we have those 3 combinations falling between the range defined by them, then we have a potential impactor, and they found 11 of them. And those are the dates. So in 2374, so it's in the very far future if we live until then. Now the second project is, again, supervised classification for analysis and detection of potentially hazardous asteroids. Their dataset is different. They used small body database. This is owned by NASA and managed by California Institute of Technology. These are their inputs. Again, we are dealing with texts, not images. We have the speed and other sort of inputs. And this is our output. So it would flag it as either potentially hazardous or not. Then it would be trained on different machine learning models, such as logistic regression, k-nearest neighbors, decision tree classifier, and random forest classifier. Those are all mathematical models used in machine learning. But which one is the best model? It was the random forest classifier. Why? Because in machine learning, to evaluate your model, you need to have the following. You need to find out the accuracy, the precision, the recall, and the F1 score. And as we can see from this table, the random forest had the highest accuracy. It is very closely resembling the decision trees. They have almost similar results. But why did we go for random forest? Random forest, think of it as like a mother, and it is a collection of decision trees. So that's why random forest outperform decision trees, because it reduces overfitting. Overfitting means classifying not hazardous as hazardous. Now, the third project is Near Earth Object AI Detection, NEO-AID. So the purpose of this is to speed up the process of identifying and tracking threatening NEOs. This is done by having a data set from the Catalina Sky Survey. It has 100 terabytes of data. This is a series of telescopes. So the model is an artificial neural network, and the result is the following. It will either identify something as high probability and alert a human to look at it, or it would flag an image as low probability, and it will tell the human to focus on something else. So the difference between project number 3 and project number 1 and 2 is that here we use images, not text. The fourth project is building a 3D asteroid model using machine learning. This was done by the FDL in 2017. Interns did that on PhD level, conducted this research. So the aim was to characterize near-Earth asteroids by estimating their shape, their size, as well as physical properties. Why? Because efficient detection and deflection of potential, because this leads to efficient detection and deflection of potential threat. The data set is different here. We have radar observations. And to create a 3D model, we need the following: spin axis orientation and period of rotation. This would give us a 3D shape like the ones we see here. So they did this using deep learning architectures to build the 3D model. They used autoencoders, variational autoencoders, and general adversarial networks. This is not the main topic of today to explain the details of those architectures. So the output of the neural network was based on the following. It will synthesize 3D asteroid shapes, and it will also speed up the process of building a 3D shape, because this takes months. With machine learning, it takes only 4 days. So here is an example. The top image shows the radar image of an asteroid. Then we have density-based clustering. It makes a 3D shape of the asteroid. Then it is fed into the neural network. Why? So that it can learn how a 3D asteroid looks like. And they synthesized data because they did not have enough 3D models. So this is another way to train or make data for your machine learning model. And this is the output, is to basically create 3D models of asteroids. Now, project number 5 is called Deep Asteroid. In 2016, NASA's Space Apps challenges, they let out data related to asteroids and other things. So this project, Deep Asteroid, made it to the global finalist list. What is it basically? It works using the following. It takes orbital elements, ephemerides, meaning the position of the asteroid, the arc length, the absolute magnitude, and the epoch, as well as the type of the asteroid, whether it's a C group, S group, X group, the metallic. It takes also the mass, the density, so that it can classify an asteroid as hazardous or not. This is a graphical representation of the neural network. So it takes all of those inputs. First 2 layers are for those inputs. It trains them. And then the following layers are using these inputs. So what are the outputs or the results of the project? So once it goes through the first layers to being trained on the inputs, it will give us the following. It will tell us if the asteroid belongs to this group, or that group. It will list them according to all of the groups with a percentage. All right. So, and the second output is from the other set of inputs. It will classify it as dangerous or not, and how likely it is to strike Earth. Coming to project number 6, detecting asteroids with neural networks in TensorFlow. This works with images, not text. So the idea is to identify, not to track or detect, it's just to identify asteroids and astrophotography data. The data set used here is by Sloan Digital Sky Survey. So how does it work? The researcher put 3 kinds of inputs. So there is a ratio of valid hues to non-valid hues, meaning asteroids, according to him, look like this. There's a blue dot here, blue pixels, and yellow pixels right here, and then there is some sort of gradients between them. Following that, we have cluster collinearity, meaning that we are expecting such kind of clustering, 3 blobs of an asteroid, and they all have the same center. They all follow one line. So this is another indicator that this is an asteroid found in an image. Then there is an average cluster distance. It measures the distance between the midpoints of the blobs or clusters. So those are the input values. They are fed into a neural network made of 2 layers, and then it can tell if what it sees is an asteroid in an image or not. Coming to the last project, the Hubble Asteroid Hunters project. This was in celebration of the Asteroid Day 2019. It's a citizen scientific project, so they let out data and they ask people to classify asteroids if they saw them. So the aim was to identify observations of asteroids in the Hubble Space Telescope images. They had more than 10,000 volunteers, more than 2 million classification. So what did those entities, specifically Zooniverse, do with those classifications? They used them to train a machine learning model, which resulted in the following. They recovered more than 2,000 trails in the HCT archival images taken between 2002 and 2020. This is an example of an asteroid trail. They also analyzed asteroid trails to obtain their brightness. Among them, 1,700 are of the solar system. You can see it here. So the blue dots represent the unidentified, the identified, asteroids or asteroid trails, and the orange one represent the unidentified. So this is another result of this project. And finally, they, alongside many other images, they saw this image where an asteroid was passing in front of the Crab Nebula right here, if you can see with me. So those are 3 results from this project, which was open to the public. So with this, we have some concluding remarks. What do we learn from all of this? First of all, integration of AI with asteroid-related project is a recent growing field in astronomy. We have various data sets and several machine learning mechanisms. So we can mix and match and explore many opportunities to classify, detect, and cluster them. And we also noticed that machine learning researchers can work together with domain-specific experts, for example, AI researchers and astronomers or experts from any other field, to speed up aspects of their day-to-day work. So we saw in the HST, the Hubble Space Telescope, instead of them doing that, the public can help them do that, so they can use it later using AI technologies. And finally, collaborative work makes wonders. So when we come together, we do great things. With this, I conclude my presentation, and thank you so much. Shall we take questions now or later? Any questions? Yes.
Your plan? You discussed what others are doing. Briefly talking about the broader plan that you are.
At the moment, we are trying to extract the data from the Gaia mission in order to prepare to do data processing for the data relevant to asteroids. And after that, we will decide on which AI deep learning architecture to use to make use and to make sense of that data.
Which way you want to go, which program you want to adopt, which way, what do you want to achieve? And of these goals, which they have achieved, or you want to have another goal?
Mainly tracking, understanding their trajectory, so we can predict that they will collide with Earth. Yes, near Earth asteroids, depending on what is available in the Gaia dataset. And then matter of selecting which AI algorithm depends on what we want.
Like collectible?
Yes, dataset?
No, the end goal would be like you track them to be collected on a
so that it can be delivered to agencies that work on mitigation plans. So this asteroid is coming, like the first project, they discovered 11 impacting asteroids in the future. So then this is our point here is done. We give it to the other agency to do its work.
Tracking them so that they are which ones are falling and which ones are falling.
Meteors or asteroids?
No, sorry,
Meteors, yes. We contacted experts from Spain, if I remember correctly, to help us with the triangulation calculations, because we need some sort of expertise in that area with orbital elements and trajectories regarding meteors. So this is kind of where we are at regarding to meteors.
AI will also be used in this.
To a certain extent, that is possible. Any other question? Okay, thank you.
So thank you, Aisha, for this interesting and informative lecture on how to utilize AI applications within different projects related to the identifying potential hazardous asteroids. So now, in terms of potential impacts and impact creators. So our next speaker, Ms. Selma, she's a research assistant at the Meteorite Center as well, and she will give us a detailed look into these impact creators on our planet. So please.
Thank you so much. Hello, everyone. Again, welcome. So I'm going to talk today about the impact creator. So be ready for the impact. So what is an impact crater? An impact crater is a depression or hollowed out area formed when an object like an asteroid or a meteorite. They cannot hear. Okay. So what is an impact crater? An impact crater is a depression or hollowed out area formed when an object like an asteroid or a meteorite crashes into the surface of a larger object like a planet or a moon. So what are the parts of an impact crater? It was numbered here from 1 to 6. Let's find out what are they. Starting with the floor. The floor, which is at the bottom, here at the bottom of a crater. It could be flat or shaped like a ball. The walls here, number 2, which are the interior sides of a crater, they are usually quite steep. And over time, they could collapse because of gravity and be like a lever of the same area. The rim, number 3 here, the rim, it's the top edge of a crater. And then the central peak, which is the higher area in the center of a larger crater. So we can find it here, number 4. And you know, it happens because of a large object. When it impacting because of a large object, then it pushed the materials to the center, to the edge of the crater, and then they will go back again, slide back again to the center, forming these peaks, as you can see here in the middle. Ejecta, the rock material thrown out of a crater during impact. So where are they? The ejecta, where are they? You can find them all around the crater. They're everywhere around the crater, but it depends on the thickness. When they are close to the crater, then the thickness will be more. When they are away or further from the crater, then the thickness will be thin. Okay, the rays, finally, the rays. The rays, number 6 here, the bright streaks of ejecta that extend away from a crater just like rays from the sun. But what factors determine the size and shape of a crater? The mass, the density, the velocity of the impacting objects, and the geology, types of rocks of the surface that the object impacts. The greater the mass, the velocity of the impactor, then of course, the larger the diameter of the crater will be. So do our solar system has impact craters? Of course. The impact craters are found on most of our solar system's rocky planets. This is very important, rocky planets and moons. Examples, Mars, Mercury, our beautiful Earth, and the Earth's moon and Jupiter's moons like Callisto and Ganymede. So what about the gas giants? The gas giants of our solar system, do they have impact craters like Jupiter, Saturn, Uranus, Neptune? They don't have impact craters. These planets are entirely or almost entirely made of gases. So there is no hard surface for the meteor to impact. You get it? There's no, hard surface for the meteor to impact. So simply when a meteor enters the atmosphere of these planets, it will break up. Welcome our moon. So the moon has many craters. The International Astronomical Unit, IAU, currently recognizes 9,137 craters, of which 1,675 have been dated. There is a recent study also. Using artificial intelligence, the Chinese scientists discovered more than 109,000 new craters on the moon's surface. And this data collected by the Chinese lunar orbiter. But who picked all those craters names on the moon? All those features names on the moon? Who are behind the scene and what are the stories? Let's find out more in this video.
Just a few seconds after touchdown, Neil Armstrong said, Tranquility Base was the name that NASA chose to give the first mission. It's located in the southwestern corner of the lunar plain called Mare Tranquillitatis, or Sea of Tranquility. This is just one out of thousands of names that have been given to geographical features on the moon. But who's in charge of coming up with these names? And are they official? In this video, we're going to look at how we began naming features. We're also going to look at who's in charge of making these names official and the strict rules around naming a place on the moon. In the year 1610, Galileo released his famous drawings of the moon. Looking through one of the world's very first telescopes, he studied the moon closely and was able to produce drawings which accurately represent the moon's features in a way that no one else had ever seen. Although Galileo had essentially created the first map of the moon, there were no place names on this map. 40 years later, a new map of the moon was created by astronomers Riccioli and Brunelli. This map divided the moon up into tranquility and serenity, looking at the great mountains and fine plains. This map quickly became the basis for naming moons, and many of the original names are still used. Fast forward a few centuries, and we have the birth of Soviet. In 1959, the Soviets became the first to send a probe to the far side of the moon. This probe successfully reached the side of the moon which had never been seen before by humans. With this new perspective of the moon's hidden surface, the Soviets started to name features after Russian heroes and places. Over the next decade, America and the Soviets started to piece together higher quality images of the far side of the moon, whilst continuing to name newly found features. Although NASA often informally names features on the moon, they don't actually have the authority to officially assign names to these features. naming features on other planetary bodies, each name has to be accepted by the International Astronomy. However, it's not just NASA that can suggest names. Anyone can submit a name to the IAU as long as it complies with their specific guidelines. Almost all craters on the moon must be named after deceased scientists or explorers who have made significant contributions to their field. The large plains that are so common on the moon must be given Latin names, which describe things like weather and other abstract concepts. Ridges like these have to be named specifically after geoscientists. Although these names may be attached to significant people within the science community, the scale of a lunar feature doesn't necessarily reflect who it's named after. Copernicus and Archimedes both have their names attached to spectacular large craters, whereas other science legends like Galileo and Newton were given features that are much less impressive. In 1970, the IAU agreed to name the largest craters on Apollo, and smaller craters within Apollo were named after astronauts from the Apollo 8 missions. Nearby craters were later named after deceased NASA employees, including the lost crew of Apollo 1 and the two space disasters. So although these names might not be familiar to us now, in the future, when space tourism is a reality, places like Apollo, Dorman, and Lovell might be as common to us as New York, Paris, and Tokyo.
Who knows, maybe one day to be New York, Paris, and Tokyo. So I picked for you two craters on the moon, Tycho crater and the Copernicus crater. So the Tycho crater, it's here, it's one of the prominent and brightest crater on the moon, as you can see here. And it was named after the Danish astronomer Tycho Brahe. It looks here, or appears here as a bright spot here in the southern highlands on the moon. And if we estimated the age here, we don't have to estimate, but the scientists estimated the age here, it's 108 million years old, and the diameter, it's 85 kilometer, and the depth, it's 4.8 kilometer. And if we come back here to Copernicus, on the left side here, Copernicus also, I have to say something, please. Regarding the Tycho also, it has a ray system. We don't have to forget this. For Copernicus also, it is a very prominent crater on the moon with a ray system also. So it was named also after an astronomer, Nicholas Copernicus, and it's estimated 800 million years old. The central peak here, as we can see here, it consists of three isolated mountains as high as 1.2 kilometers above the floor. Now the question is, why does the moon have more craters than the Earth? Anybody knows? Just guess. Anybody knows? Very good. You give a great hint. Okay. So the Earth has processes, that can erase almost most of the evidence of the past impacts. The moon does not. Once something hits the moon, that event will become frozen in time, while the Earth, it brushes the impact craters and moves on with its life. It's completely different. So let's talk more about these processes. Erosion. First of all, the erosion. You know, the Earth is a changing planet. So look here, the past is completely different from the present, and the future will be also different, And the Earth also, it has atmosphere, weather, plants, water. Look here, everything is on the Earth here. So all this will act together to change our beautiful planet, the Earth. But the moon does not have plans or weather to change whatever it is on its surface. The second one, the tectonics. The Earth consists of plate tectonics. These plate tectonics, they are moving in different directions, either divergent, convergent, and so on. So because of this, new rocks will form and the Earth will get rid of other rocks. So it is recycling its surface every time through its long history. The Earth before, as I said, is not like the Earth like in the present and will not be like in the future. So the moon doesn't show any plate tectonics for billions or since billions of years. The third process, volcanism. The volcanic flows uncovered the impact craters, but it is less important in the solar system than the Earth, as I said, because it is recycling its surface every time and it is changing. The moon in the past, it showed volcanic activities, but since over or around, we can say 3 billion years, there is no volcanic activities. And one of the proofs that help us also to, it's an evidence, okay, that nothing really changed on the moon. What? The first footprint of Neil Armstrong on the moon in the mission of Apollo 11. We can find it there. It's not going to be changed unless there are some impacts, okay? So let's have some examples about the impact craters in our solar system. Welcome, Iapetus. Iapetus is the third largest natural satellite of Saturn and the 11th largest one in the solar system. And here you can see Turgis. Turgis, it's the largest impact crater on Iapetus. It has a diameter of 580 kilometers. And now welcome Mars. Mars, it has a spectacular crater on Mars. Actually, many craters you can find on Mars, but I picked for you this one. This one formed between September 2016 and February 2019, estimated 15 to 16 meters wide. Now, Callisto. Callisto is the second largest moon of Jupiter. So in Callisto here, you can see so many bright dots here in the photo here on the right side. So many bright dots. These actually are impact craters. And these impact craters or these bright spots, okay, represent or testify many or long history of impacts on this moon. So if we go here to the right side, if we here concentrate on the right side here, this is also a picture from Callisto. You can see unusual structure here. This one, it's unusual structure in the solar system. It has a wide of 4,000 kilometers and it consists of at least 25 ring arcs. So maybe this due to what? This is due to the impact on the icy lithosphere on this moon here, and this fractured later on fractured. And when the basin collapsed. And now let's go back to our Earth. There are 190 confirmed impact structures, okay, on Earth according to the Earth Impact Database. Perhaps the most famous one is what? Or the largest also, it's the Chicxulub here crater in Yucatan Peninsula in Mexico. Why it is very famous? Because it's related to the extinction of dinosaurs. That's why. And you know, many scientists think that the large meteorite created in this crater here, measuring roughly 10 kilometers wide, triggered the extinction of the dinosaurs and animals and all the plant life, because there are side effects of this asteroid. It's not just attacking or impacting. No. The weather change, the volcanic activities becomes more, and so on. So many side effects because of this attack. The crater is 180 kilometers wide and 20 kilometers in depth. But this one is not visible. This crater is not visible like what? Like which crater? The Arizona or Barringer crater. The Barringer crater or Barringer meteor crater is located in the desert of northern of Arizona. This one represents the best preserved meteor impact site in the world. It was formed since 50,000 years ago, and the depth is 170, the diameter is 1.86 kilometer. And who is the impactor? Who is the impactor? It's moving here, but what is the type of this impactor? Let's find out. Iron meteorite. The iron meteorite, approximately 50 meters across and weighing several 100,000 tons, approximately we can say 300,000, okay, attack this area or the desert of Arizona in a speed of 12 kilometers per second. So let's find more about this in a very quick and short video.
In the 1960s, that was Earth of a more celestial, yet just as explosive origin. 50,000 years ago, Asteroid mammoth and giant ground squirrel wanted these lands. A massive asteroid collided here. The impact energy was about 10 megatons, equal to more than 20 billion tons of TNT. Ancient meteor crater, the first geologic star ever confirmed to have been created by a collision from outer space. Hundreds of other craters have been identified since, but Arizona's remains one of the most spectacular.
And here we come to the end of this quick presentation. Thank you so much. Thank you so much. And thank you. Do you have no question? No question? Or you want to eat? There's a lunch. Okay, thank you so much. Thank you again.
So thank you, Selma, for this interesting presentation on the impact craters, not only on Earth, but also on other celestial objects. So we reach now to almost the end of this event, but we have like a concluding remark from Professor Ilyas to conclude and close this event. So please, Professor.
Thank you very much, all of this presentation. And as you saw, so we went to talking about previous impacts and maybe also about future impacts. And as you saw in so many applications, so many videos, this world is full of these natural space debris. So, and as I said in my opening words, it is the responsibility of each one of this whole world. Each country is responsible to do its duty in terms of observing this hazardous object, because they are by the billions. We have mapped, I believe, most of the big ones, and we know exactly their orbits. That's very, very important. But we need more. We need at least to detail those small ones, because even if it is only a 1 meter rock or maybe a 5 meter rock, can do a lot of damage, especially if it does fall into urban locations. So the impact will be quite catastrophic. You saw the Barringer crater. So it is said that every 50,000 years, we get the visit of a similar rock. So the Barringer was about 20 to 50 meters. So, and you saw how big it is, 1.2 meters. So it is a very, very huge impact. using modern means like AI, artificial intelligence, as you saw it with Aisha, is very, very important, because we have billions of these rocks. Okay, which one may pose a threat to us? So we can't follow billions of them. So we can let the machine does the work for us, and it will pinpoint those possible threats. And we may have at least, let's say, maybe 1,000 of them. 1,000, we can follow them. But if we have 1 million, it will be quite impossible. So we need to use these modern tools to observe. I saw about a month ago, maybe a month and a half ago, this about 2 weeks ago. I'm sorry, two and a half weeks ago. This Gaia released data, and they mentioned that Gaia was able to observe 150,000 asteroids. So my team is going to look into that, inshallah, and they will make sure that some of these 150,000 asteroids do not pose a threat to us, because it is our responsibility, because we have the means. We have the Sharjah Optical Observatory that can observe these asteroids. We have the UAE Meteorometry Network that can also do that. You saw that up to now we have observed 42,000 meteors, mashallah, and some of these are artificial, are falling rockets pieces, and we have the possibility of observing them, because all of this asteroid observation, meteor observation, doing this, all of this will fall under one theme: SSA, space situational awareness. Every country has a program. So we have lucky that at the University of Sharjah, especially at the Sharjah Academy for Astronomy, Space and Technology, we have those tools. We have optical observations. We have hopefully in the near future we're going to have radio observations. Yes, of these meteors as they pierce into the Earth atmosphere, because we can hear them in the radio band. So all of this hopefully will make the Sharjah Academy a better place, a good research center, because I always, and you believe my researchers are sick of hearing that, we are the best in the MENA world in terms of space science research. We cover everything, from pure astronomy to astrophysics, to radio astronomy, to optical astronomy. So we cover everything. So we have the right research labs, we have the right research assistant, we have the right faculty members to have a good future. And we are expanding. You saw the UMMN would like to add 3 more stations. Okay, hopefully very soon we're going to have the Wad Hulu Observatory. It is about 17-inch, and hopefully we're going to add 1 meter optical telescope to be good for the UAE, and also for the whole Middle East, inshallah. So we are also expanding our radio astronomy observatory. So you may have seen some of us who know this east side. We used to have 3 dishes. We did dismantle them last week. So Hissam and us, we took them out because we are adding 6 more radio telescopes, and hopefully we're going to build a 1 kilometer radio interferometer, because usually in astronomy we say bigger is better. So the larger the system you have, the better in terms of observation. So we are moving toward the right, I believe, the right track, and having our present research assistant, having our interns, these beautiful faces, mashallah, male and female, don't understand me wrong, whatever. Also having, I believe I see some of my summer students here, so it's good. So, and hopefully some of you as interns, some of you maybe also part of us, inshallah. So we are moving toward the right track. Unless someone says, no, you are not moving, and I will not invite him to lunch. So thank you very much. So now we have another program. Okay, you need to go upstairs. Marwan and his team are waiting for us, mashallah. Fatima, she's waiting over there. We're going to have for you a nice free planetarium show, mashallah. And after the show, we meet in the cafeteria. We have a beautiful lunch for you, free of charge. and hopefully you will enjoy it. Thank you very much for being with us. So Fatima, you will lead them to the first floor, please, to the planetarium room.